Hey everyone, we're here to talk about surfing the LLM wave. We can't opt out, and neither can you. I'm Erika, I'm Hex's head of data, and I'm here with Amanda.
Hi, I'm Amanda. I'm a senior analytics engineer at Hex.
And we actually have someone else who's helping us with the talk today, but he's not actually on the stage right now. And he just joined Hex. He's a new hire. And the data team didn't actually hire him. Our stakeholders did, because he has this insatiable appetite for answering quick questions. He's extremely online. He's really, really good at Pandas syntax. He has this weird fondness for SQL that screams that we don't love and subqueries. And if you're following along, you may have guessed that Patrick is, in fact, an LLM. And people really want him to be successful at this use case of taking a question in natural language and answering it in SQL. And he's not getting the questions right all the time. And people are starting to wonder if maybe the data team is not very good at what we do, or maybe our data is a mess and our warehouse is really hard to use, and that's why Patrick is not, in fact, successful. But the problem is that people are trying to use Patrick for basically his worst possible use case. And the reason is that for all of us, doing something yourself and not waiting on someone feels much better than getting in line, waiting for something to be turned around, interrupting your flow of thought. And what we're here to talk about today is that someone is going to hire an LLM onto your team. In fact, it may have happened already, and just nobody told you. It's something someone's trying on the side or they've started experimenting with. And if you're feeling some kind of way about that, I want to introduce you to what I call the chaos versus control spectrum for data leaders and data teams. So I want you to think about if you agree with a statement like this. I'd rather somebody wait on my team than get a 70% correct answer. It should be really hard to get different answers to the same question. I'm fine with having people having access to the data warehouse as long as they have some training first so they know how to use it. And if you agree with a lot of those statements, you probably fall in some senses towards this control side of the spectrum, which makes sense. We're at DBT conference, and DBT is a control tool. Organize your transformations, test your data, have documentation that everyone can use and answer questions with. But the problem is LLMs are kind of fundamentally chaos-oriented technology. They don't even answer the same question the same way twice. Sometimes they hallucinate. So in a world where LLMs are a stakeholder of your data team, we all have to figure out how to be more comfortable with this chaos side of the spectrum. And at the same time, this can be really anxiety-provoking for data people. Are we less relevant? Is there going to be less headcount on the data team in the future, but the expectations are just going to keep going up? And how does this change how I have to do my day-to-day job? At Hex, we've had access to these tools integrated into our Hex platform with a feature called Magic since February of 2023. And because Hex has such a strong dogfooding culture, everybody has been trying to use this feature all the time at Hex. And it has complete access to our data warehouse. So we are that data team that is trying to make these LLMs successful at this really, really hard job. And so we're coming to you today with your game plan for this change that's coming at some point in the future to you and your data team. And the first thing is, I don't really think this is a change that can be stopped. So you want to put yourself in the position of helping lead the charge, right? Nobody likes to be told no, much less your stakeholders that feel like they're not getting 100% of what they want. So you want to be a partner, not a roadblock, to the people that are trying to figure out how to innovate with these technologies. Finally, we're here with a little bit of a silver lining for this kind of scary, maybe depressing, you can't opt out sort of intro, which is that what's good for LLMs is also good for humans that are trying to use data in your company. And finally, Amanda's going to go into great detail about how we put our new hire Patrick to the test and what the levers that data teams can pull to increase his accuracy are.
Thanks, Erika. Great. So when we were onboarding Patrick, we had a hypothesis. Maybe he's not so different from our organic matter coworkers. Maybe what makes data work for our human stakeholders is also going to help Patrick succeed in his new role. Because ultimately, that's our job as data practitioners. We create data assets that are sensible and usable and delightful for our stakeholders. And that group of stakeholders just now includes Patrick. So we ran some experiments, and we put Patrick to the test. We tried out changing schema access and organization. We played around with our modeling conventions, field names, and also the quality of our metadata and documentation. So before we dive into how Patrick's performance review actually went, it's important to frame this in the conversation of benchmarks out there that you might be reading in blogs or in academic papers. As you might remember, Patrick on his resume told us that he graduated with about an A- in LLM SQL generation. He gets about 90% of questions right, according to him. And that would be great to hire someone right off the bat who was 90% accurate and who also didn't require us to pay for like healthcare coverage, right? He's pretty cheap and he's really good at his job. That's his shtick. But here's the thing. Patrick hasn't ever had a real job before. All of his 90% acclaim is based on past academic accomplishments, and we don't know if those are actually good predictors for his success in the workplace. Which kind of makes sense, right? Like we can think back to our own academic experiences and how applicable they really were to real world work once we entered the workforce. So let's compare our eval set with what we see out in the industry. I'm going to be using a pretty well-known and open source eval set called Spider to do this comparison. Spider is very broadly used for a lot of the academic benchmarking work that you might see online, but it's not necessarily reflective of real-world data work, as we'll see. So let's compare sort of middle-of-the-road examples from each data set. To get a good apples-to-apples comparison of the two eval sets, I ordered the target queries in both sets. These are like the answer keys to the test, basically, within each eval set from the least number of characters to the most number of characters. And of course, character count is not necessarily an indicator of like complexity, but it's a good enough proxy to demonstrate this point. So here's an example of our median length question in Hex's eval set. The prompt is, how many meetings were booked in the previous quarter? And the SQL needed to answer this question correctly is below. What you'll see is that the prompt does not inherently match any sort of field name or table name in the answer query. It requires a join with this dim dates table using stage 0 at, which the computer will have to know means a meeting has been booked. And it also has filters that haven't even been sort of hinted at in our prompt. This is a question that our real-world human stakeholders also ask all the time. Compare this with Spider's median eval. So the prompt, show all the locations with at least 2 cinemas with capacity above 300. It's very straightforward. Also very reasonable to grok, and importantly, all the keywords in this prompt map to either a table name or a field name. So any sort of person with very foundational SQL should be able to answer this question with relative ease, looking at the data sources. The takeaway here is that academic benchmarks are useful for furthering our understanding of LLM generation of SQL, but they're not applicable to our real-world everyday work, which is what Patrick is trying to do with our stakeholders here at Hex and within your own companies. OpenAI had a convention earlier this month, and Stephen Heidel gave a talk where he said, academic benchmarks are not your tasks. These are inherently different things. You cannot compare the 90% success that you read about in blogs to what you can expect Patrick to do in your own company. So diving into our eval set a bit more. Our eval set was comprised of 90 questions, 90 prompts. This is another example. How many customers do we have in the segment? Again, these are questions that are easy to ask, that our stakeholders ask all the time, but they're hard to translate into SQL. In order to answer this question effectively, Patrick has to know what a customer is, what a segment means, and what stands for in order to get the right answer. He gets one chance to answer the question, so no nudges or clarifications or hints after he gives us his first SQL output. And in our eval set, he has to do this whole test 6 different times. So we first put him to the test against our own Hex data warehouse, the data warehouse that all of us at Hex have access to. And then we created 5 additional flavors of our data warehouse where we pulled one of 2 levers. The first lever we pulled was changing what Patrick actually has access to. We either expanded the access from our default data warehouse so that he has access to all sorts of schemas and databases, or we restricted it even further with a tool called endorsements. In the other set of experiments, we tested his access to quality documentation. everything from taking away all docs entirely, making it a closed book exam, to writing really, really excellent docs, even better than what's in our data warehouse today. This is basically like the crib sheet of your dreams for a test. And to get questions correct, to be classified as a right answer, Patrick has to be able to use a valid table to answer the questions. He has to know where to look. He has to pull in the right columns and use the right logic. And he also has to avoid hallucinating or otherwise erring in his SQL syntax. So let's see how he did. So on the left, or right, I know my directions. On the right is our Hex data warehouse as it is today. It's one database. There are 3 schemas. It's very tidy. We love it. We compared this first to this sort of like free-for-all. He has access to everything that's ever been in Snowflake, where this includes our Hex data warehouse, but also Erika's and my development DBT schemas, our PR, CI schemas, the raw databases that are in there. And when we see how he does, it's pretty telling, right? So in a free-for-all world, Patrick gets 10% of the questions right, 9 out of 90. In our current, today, Hex data warehouse, he gets 38% right, which is better than 10%, but it's definitely not the 90% that he promised us when we hired him. And let's take a look at why that is. So the first thing that Patrick has to do is find the right table to use for these questions. And in a free-for-all world, he has a really hard time finding the right question, or finding the right table. This is the table retrieval problem for LLMs. So this makes sense, right? Maybe there is a dim dates table in Hex data warehouse, but it's also in my dev schema, in Erika's dev schema, in Caleb's dev schema. How does he know which one is the right one to pick? It's a lot harder in this free-for-all world. In our Hex data warehouse, table retrieval is a lot easier. Patrick is able to find the right tables more frequently and rank them towards the top of his list so that he actually knows he should use that one. All right, so let's pull the lever the other way. So going from the baseline, let's make this even more restrictive for Patrick and tell him that some of these models are endorsed. These are flagged as like being very important or very commonly used models. And so Patrick has a hint that maybe these are the ones that he should be looking at more and more. So again, we have our 38% baseline. And when we endorse models that we know that Patrick should use, he goes up to 46. And again, this table retrieval window gets much more narrow. He's much better at saying, OK, I trust you on your endorsements, and I will use these tables to answer your questions. 46 still is not 90%, though. So let's try pulling some other levers, including documentation. A tidy warehouse makes a difference. Endorsements and other sorts of hints make a difference. But maybe we can help Patrick further by telling him how to actually use the tables or the fields that are in the tables he's selecting. We know he loves reading docs about Python and regex, so maybe he'll like reading our DBT docs also. But on the other hand, we also know that writing documentation is a real pain sometimes, and that our documentation can be varying degrees of quality. So let's test them against all those quality options. So in my example prompt from before, how many customers do we have in the MM segment? Patrick will need to use this field, account segment type, to answer this question. So let's play around with how we document this. If we're being honest with ourselves, in a lot of our DBT projects, it probably looks like this. You know, life happens. Not everything gets documented, especially when you have a bunch of models in your project. So maybe he doesn't have any sort of documentation to rely on. Now, if we're strapped for time, we can also hire an LLM like Patrick to write our docs for us. When we do this, we get something like this. The segment type of the account. Possible values include enterprise and mid-market. OK, maybe better than nothing. It's a little tautological. It doesn't really tell us a whole lot, but it does give us some examples of what kind of enums are in here. This is what's actually in our data warehouse today. So we're going to tell you how the thing is calculated. We're going to give you the full list of enums. We're also going to put some disclaimers, like that we're available. So maybe Patrick will know that it's not always non-null. We can make this better. We can give you everything that's in our baseline, and we can tell you synonyms. So things like small mid-size is also called SMB. Mid-market is also called MM. We can also give you use cases, tell you what this field is used to calculate. These synonyms are really important because stakeholders will talk to LLMs in everyday language. They will use business jargon, but Patrick, poor Patrick, he doesn't get to hang out with your team at meetings or around the proverbial water cooler, so he has no idea what these words actually mean unless you tell it to him specifically. So, this is what happens in Patrick's test when we play with his documentation. Again, we have the 38% baseline of our normal today Hex data warehouse. Honest docs aren't a whole lot worse, 33%. So why does Patrick do nearly as good in our Hex in a no docs world as he does in our Hex data warehouse world? And why does he do better than the free-for-all world that we showed earlier? We think this is because even without docs, Patrick still gets a boost from sensible warehouse architecture, having a select number of schemas, only one database to work with, and the models within have a standardized and consistent sort of naming convention. Booleans are prefixed is, categorical variables are prefixed cat. These aren't documentation in and of themselves, but they do provide some sort of hints and patterns that Patrick can pick up on. AI docs is nearly as good as our Hex data warehouse. That's not because Erika and I are really bad at writing docs, but because these help describe what they see. This is just telling Patrick what is out there. They're still flagging behind our baseline, though, because they, as you saw from the example, have not told us what to do with them in terms of business logic or metrics development. They don't have exceptions or disclaimers. It's like asking a new college grad to write your docs on their first day, right? Like, they can describe what they see, but they don't really know how to use it. Best docs, though, when we give Patrick a really good crib sheet, we get to 51%, which is great. This is a big jump from our baseline. But it's still a pretty wide chasm from that 90%. So did Patrick lie? Do we fire him? I'm not in charge. Erika's our head of data, so I'm going to let her tell you what we do with Patrick now after his performance review.
Okay, so awesome. So as Amanda said, Patrick told us he was 90% accurate. It's based on his academic performance. I think some of us in the room, including myself, have been that overly optimistic new grad. And then he actually comes in at 51%, which we feel like is pretty honest compared to the industry evals we've seen. We took a lot of pains to make sure that this 90 questions covered things people are actually asking Magic at Hex, questions our stakeholders sometimes struggle to find the answer to in dashboards. But it's really not good enough to claim self-service success. Of course, as a data leader, you might be thinking, oh, I could do things like teach people to write better prompts. I could help them understand the key dimensions in our data. But that's starting to sound a lot like the same sort of like bread and butter data team things we've tried to try and make self-service happen forever, right? And it's still this sort of illusory goal. With this kind of accuracy, Patrick is going to be best at helping people like me, or some of our beloved friends of data in Hex that really love to dog food and kind of know their way around the warehouse already. These are the sort of folks that might be able to spot like a small error that Patrick made, like hallucinating MM instead of mid-market, and get it corrected to the right value and go on their merry way. Of course, there's another way to codify your business logic besides documentation and a clean warehouse, and that's semantic layers or semantic specs. And this 51% result was challenging enough for us to think about like standing here on stage and being like, woo, 51%, y'all, we did it. That we wanted to run a little quick experiment. And to get this done, we had to subset this 90-question eval set down to 35. Why 35? Well, those 35 questions could be answered with just 3 semantic models joined to 2 other tables. So we scoped it down so that we could pull something together to have a result to share with everyone today. And on this eval set, this 35 questions, the baseline accuracy rate goes up to 48%, which suggests to us that this general question set is a little bit easier than the 90 that we originally asked. We took out some of these like edge cases, and a lot of the questions are like the examples we've shared, like count this metric for me by this other segment. We can give Patrick a semantic spec prototype that looks something like this. This is going to be really familiar to you if you've used something like LookML or dbt semantic layer. It's got a model for customers. a dimension for account segment type, which we can imagine includes all the documentation Amanda shared. We have a measure for total customers. We tell Patrick how to calculate that in SQL. And then we also might have common filters that people use expressed in segments. And what this does is it takes some of the guesswork out for Patrick. And he does a lot better in this sort of scenario. The reason we're showing a range here, this 75 to 88%, is that we experimented a bit with the ways we prompted Patrick, how we instructed him to use the semantic spec. And this space is really evolving so quickly that we felt like this was a better representation of the results. In this evaluation, Patrick still had the option to not use the semantic spec. So he could look at the question, decide if the semantic spec could help him answer it, and if not, follow the table retrieval to SQL path that Amanda was talking about. You can tell by looking at this spec that Patrick has everything that he would need to answer the how many customers are in the mid-market segment question. And since we gave Patrick full coverage of this 35 questions in the semantic layer, this is kind of like a best case scenario sort of result, we think, right? Like no semantic layer, no matter how good, is going to be able to cover 100% of all of the questions your stakeholders are going to ask. So where does this leave us? Is there hope to maybe control all of this chaos? What's available now to anyone that's using a tool like Hex gets us to 50%. But there's some hope that we could see better performance in the future, right? Like better integrations between semantic specifications and LLMs. LLMs, the companies that produce these models, are always announcing new flavors for different tasks and new improvements on the baseline. And this is a really active area of investment and development for a lot of companies. This space, like one of the biggest challenges of this talk is that this space is moving so very quickly right now. In the meantime, what you need to develop is a viewpoint for your team and your stakeholders about how this change is going to come to your company. We heard in the keynote earlier about Copilot features arriving into dbt soon. So even if somebody at your company, like a stakeholder, is not trying to hire Patrick, this feature might just like show up in the release notes, and then you have to think about like, what does this mean for me and my data team? Amanda covered a lot of different ways that we can influence the accuracy of LLMs, but as a data leader and a data team, you really need to have a viewpoint on what this does for your company, why you're using it, and how it fits into the problems that you solve for your business, because there's not infinite time and infinite resources, right? Like, we can't invest in all of these strategies at once and just become like documentation writing engineers. Once you have your strategy, you can start to think about prioritizing your investments and your improvements. So there's probably going to be some basic enablement, like when to use these technologies. We think observability is a really big opportunity, both in the product space and for data teams, like understanding how and why these tools work, and if they're working for the people that are trying to ask and answer questions. Of course, our standard bread and butter: organize your warehouse, document your models. You're supposed to do it. It helps everybody, including the humans that are trying to use your data. Control over context. I think this is a really big one. It was kind of surprising to us that Hex's endorsement features, which is basically like going down your warehouse and starring the tables that people should use, did almost as well as these like really laboriously written good docs, right? Like 46% versus 51% on our eval set. And then finally, if people are trying to hire Patrick at your company, if your team is thinking of trying to hire Patrick, we think you should be thinking about a semantic layer. At Hex, we're like this small 100-person startup. We don't have like a governance reason to necessarily invest in a semantic layer, but we do have a lot of people that love our magic feature and want to use it to use our product internally in the company. And for us, that feels like a compelling reason to invest. At Hex, we're trying to do the best we can to make sure we get these benefits of LLMs that people love. It's always there. It knows Pandas syntax. It can help you right there. You don't have to wait on the data team. But with a minimum of hallucinated chaos. There's always going to be a bigger demand for insights than any one data team of humans can ever meet. And in our ideal world, the LLM is helping serve some of those dumb questions we don't really want to answer for the 1000th time anyway, so that the data team can focus on higher order work. As we wrap up, I want to thank some folks at Hex that made this talk possible. Brian and Olivia from the team that works on Hex's magic feature are here in the audience with us, and they were helped by Charlene Chambliss. Helped us with running the evals and understanding the results. Jamie Chen from our brand design team made the fabulous chaos graphics and all the graphics you saw in the talk today. And then Claire, Caitlin, and Barry gave us feedback on our talk structure. So thanks so much for your attention today, and come see us at booth 209.
When you're passing like the model documentation into the prompts, are you guys like transforming it, or I'm sorry? When you guys are passing the model documentation into like your prompt for the LLM, are you guys transforming it at all, or just saying, here's some DBT YAML and pasting in the YAML?
Yeah, so that's actually handled automatically within the Hex platform. So we have a deep integration with DBT's metadata features. So the documentation that we write into DBT is available for all of our stakeholders in Hex's data browser. And then when that table retrieval process is going on to get the correct table for the prompt, it's looking at the table descriptions and the column descriptions to try and decide what to pull back. And there's also a feature within Hex called Data Manager, which is what does the endorsements or like the starring or recommending of tables. And you can directly update what the model has access to in the docs there within Hex.
Hi, can you talk a little bit more about how you get Hex Magic to talk to the semantic layer? If you're not using DBT semantic layer, but more of a looker shop like at Fivetran.
Yeah, that's a great question. So for our prototype, we scrapped something together just so that we could get this eval set running. And this was kind of like an experiment that our folks on the Magic team helped us run so that we could have something for the talk. I think we're going to see a lot of new integrations emerging as companies continue to innovate in this space, because it's just this like, you know, the best possible crib sheet that Patrick could have is like the answer key, which is the semantic spec. So I think we're going to see all sorts of vendors try to integrate with each other to take advantage of what already exists. We are very happy DBT customers. And I should say that Hex also has an integration with DBT's metrics layer where stakeholders can just consume that metrics layer directly in a Hex project from DBT. Great question, thank you.
From the things that Patrick did badly, were you able to classify them into these are the most common failure types?
Yeah, that's a great question. I'll let Amanda chime in too. Some things that definitely come to mind are like hallucination, like making up a column that doesn't exist, that's some business terminology that was in the query. There were some weird ones around joining, like that quarter join that Amanda showed where like he might forget to truncate it to a date, or if he was trying to calculate a conversion rate, it would always be 100% because of the way he did the join. He accidentally filtered some records, stuff like that.
Table retrieval was also like the first big hurdle I think that Patrick had to clear. Even in our like, you know, most condensed form, like even in an endorsements world, he has a smaller list of tables to choose from, but he would still sometimes pick the wrong one. And that kind of, you know, it makes sense that our data models, you can answer a question more than one way, right? There are common fields and common semantic conventions across lots of different models. And so even though he had a much smaller list, he still sometimes saw something he thought was right in one of those other endorsed models and would choose that. So there's no like perfect shot in the dark to table retrieval.
Yeah, I guess I would say the other thing is he was bad at like figuring out like, should I use an aggregated like dimension table where I can just divide some pre-computed things by each other, or should I use like a time series table and like recalculate it, recalculate the metric from like the data that's powering those aggregations? Yeah, great question.
I'm wondering if you looked into giving Patrick access to other queries written by data scientists within the company, since as a data scientist myself, like I'm often interested in the queries that my teammates have written, and I'd love to have like natural language search on like queries that other people have written so I can like use the same logic. And so I imagine that might be useful for something like Patrick.
Yeah, this is kind of my dream, that like I don't have to worry about writing a semantic layer, and it just kind of like writes itself, and I police that instead of having to do like all this really slow work. We did not do anything like that in our set of experiments, but I think that's a really interesting concept. We've got one in the front and one right there on the left.
When you use the semantic layer, was it still generating SQL, or was it like calling like an API that uses the semantic layer? In other words, was the semantic layer writing the SQL or the LLM?
Yeah, so what we gave him was like something similar to that semantic spec prototype that you saw on the screen, So this was like a custom prompt rigged up for the purposes of doing this experiment, but the output was still SQL.
Okay.
And I should say that Amanda and I also went through and hand graded all of the SQL. We do have a framework at Hex for automatically evaluating the results of an LLM against a particular eval set. But Amanda and I found a couple instances in looking at early outputs where, like, if your analyst answered this question that way, you'd be like, oh, creative. But like, that's not the way I answered it, but it's like valid. So we actually graded 600 output LLM queries each.
I don't ever want to look at a query again,
I got bad news for you.
says the analytics engineer. Yeah.
Yeah.
And one more quick thing. So when the accuracy goes up, let's say at some point it gets up to 99%, do you see this like a valid use case that people are going to be using, or is this the ideal interface for people with
Yeah.
data, or is some sort of like self-service BI still better?
Yeah, that's a great question. I think the modality depends a lot on like the preferences of who's doing the analysis, what they want to do, how consequential is the decision. Like, do I just want to know how many mid-market customers we have because I'm curious? Or am I trying to make like a big decision at the company that goes through a one-way door that we can't walk back out again? I think when people, like decision makers in companies, are making those kinds of decisions, they're still going to want a human partner to think about all the angles and flag for things that they might not be thinking about and help them make that high quality decision. Like, I think we're a very long way from you just chat Patrick and then change your company strategy. Thanks so much, y'all. We'll
Thank
be
you.
up front for a while.